In this lecture, we look at fluids, or things that flow. There are two basic classes of fluids, liquids and gases. Fluids have no inherent shape. They tend to take the shape of the container that they are in. Gases are easy to compress. In the movie that's being shown, there is a container filled with gas and a piston that's being pushed down with greater and greater force. As the force is increased, the density of the gas increases. That is, the mass per volume increases because the volume is getting smaller. We are also seeing a gauge on the side, or a meter on the side, that's changing as the force goes down. The greater the force, the higher the number. This gauge is recording the pressure of the gas. The pressure is measured as a force per area. 1 atmosphere pressure is equal to 1.01 times 10 to the 5th newtons per square meter. So this gauge could be calibrated in atmospheres, or newtons per square meter, which are also known as pascals. So this gauge could also be in 10 to the 5th pascals. There are a couple other units that are commonly used for pressure. 760 torr is equal to 1 atmosphere, and also 14.7 pounds per square inch, the English units, are equal to 1 atmosphere. Liquids, in contrast to gases, are hard to compress. So if we have the same apparatus where we're increasing the pressure over time, we see that the piston does not move, so the density does not change, but the pressure goes up as we increase the force. So as we increase the force, we see the pressure goes from 1 atmosphere up to 1.6 atmospheres, but the density does not change. Let's look at a few common densities in various places in the universe. At the center of the Sun, the pressure is 2 times 10 to the 16th pascals. The center of the Earth is 4 times 10 to the 11th pascals. The best we can do in a laboratory is with a diamond anvil cell, where people can create 3 times 10 to the 11th pascals, roughly the pressure at the center of the Earth. At the other extreme end of pressures we can create, the smallest pressure we can create in a laboratory is 10 to the minus 12th pascals. Let's look at an example. Hyperbaric chambers are oxygen chambers that can run at pressures higher than atmosphere, and they have been used to treat a variety of medical conditions. They are first used for decompression sickness, or the BEMS, but now they are used successfully also for gas gangrene and for carbon monoxide poisoning. The chambers run at a roughly 600,000 pascals absolute pressure, or a pressure difference of 500,000 pascals above atmospheric pressure. Most of the chamber is a steel cylinder. However, there is a glass viewport for monitoring the patient that is 5 centimeters in radius. So what is the force on this viewport due to the pressure difference? Well, pressure is equal to force divided by area. The force equals pressure times area. Pressure times pi r squared, then, is the force on the circular window. Plugging in the values for the pressure, we have 500,000 pascals times pi times 0.05 meters squared, which gives us 3,927 newtons. That's equivalent to supporting a mass of 400 kilograms on top of the glass window. Seems like quite a bit, even more when you realize this is the equivalent to an 880-pound gorilla standing on top of the window. So we better make sure that window is quite thick.